Assalamualaikum. My name is Muhammad Iqbal Bin Jamal Asri and I am under supervision of Dr. Ummikalsom Binti Abidin. So today I will be presenting on my final year project. My title is The Effect of Aspect Ratio on Focusing in Spiral Microchannel. My background study: Spiral microchannel is a microfluidic device that has been used to do cell separation. The use of microfluidic device in performing cell sorting has been widely used in biomedical studies. Miniaturized device offering similar capabilities that exploit a variety of physical principles. So, my problem statement is how the geometrical design of the spiral microchannel affect the hydrodynamic flow and how far the difference between theoretical result done through calculation and the result from simulation using console software. My objective is to design two spiral microchannel with two different aspect ratios, to perform theoretical analysis of spiral microchannel on the fluid flow with different aspect ratio, and lastly to perform finite element analysis of spiral microchannel flow with different aspect ratio. So here I will presenting my literature review on microfluidic sorting techniques and literature review finding. From my literature review, I found that there is two classification of microfluidic sorting technique, which is active and passive. The difference between these two techniques is that passive technique generally rely on internal effect of the flow, whereas active technique rely more on the applied external fields. This is proven by Zhou and Chung Nguyen on 2010. Passive sorting has high throughput and does not require external source to perform separation. Based on previous study, it is found spiral microchannel exhibit high separation efficiency compared to other designs. Based on journal from Bhagat, they designed spiral microchannel with 5 groups of 100 micrometer times 50 micrometer dimension microchannel with a complete separation of 7.32 micrometer and 1.9 micrometer size particle. Their microchannel design have two inlets and outlets to vary the ratio of the lift forces to the din forces acting on the different sets of particles. From the result, we can see that the smaller size particle with confinement ratio less than 0.07 are focused on the outer half of the microchannel, whereas the larger size particle, which is the confinement ratio less than 0.07, focus near the inner microchannel wall. So here is their design and their result. From journal by Navidita on 2013, they have successfully demonstrated a continuous separation of blood cells from blood samples using an Archimedean spiral microchannel device with 3 different outlets. They produce microchannel size of 250 micrometer times 75 micrometer with a rectangular cross-section. The flow parameters were optimized by injecting fluorescent particles ranging from 7 to 20 micrometer at 1000 microliter per minute. The separation efficiency obtained was 100% with high throughput for their spiral microfluidic device. So here is their finding and their result. Next, I will go through on methodology. So here is my flowchart for my research. My first methodology was on theoretical analysis on din flow and initial focusing. Din flow is the strength of secondary flow. It is characterized by din number. It is generated at the cross-sectional plane due to the inherent velocity difference by the curvature of the channel. It is from din 1928. So here are the equations that explain on the behavior of flow. The curvature ratio influences the shape of the din vortices formed inside the microchannel. The magnitude of secondary flows is directly proportional to the flow velocity and channel cross-sectional dimension and inversely proportional to the radius of curvature of the channel. Next is initial focusing. As the particle moves closer to the channel wall, the rotational wake around the particle is disturbed due to presence of the wall, which results in the wall-induced lift force. it was cited from Kutego Danahali on 2009. So here is the equation for the forces exist in the microchannel. Equation to determine the drag force was derived by Okawara, while for the lift force it was derived by Osomolov. And here is the shear rate parameter, which will explain why the lift forces tend to have a larger value for a smaller cross-sectional area. In the expression for the lift force is that there is a factor called shear rate of fluid. Based on a study by Carlo on 2007, particle confinement ratio is also a parameter that plays a critical role in the focusing mechanism. If the confinement ratio is larger than 0.07, inertial lift dominates over the thin drag force and hence a narrow focus band is formed near the inner wall of the channel. And if less than 0.07, then drag force the particle to move towards the outer half of the channel. So I will go through my methodology on design on spiral microchannel using SolidWorks. So here is the fixed parameters that I use to create or to design the spiral microchannel using SolidWorks. Next, here is the final result on spiral microchannel with aspect ratio 1:1 and 1:2. Next, on methodology on expected result analysis. Before proceeding to calculation analysis, there are several parameters that need to be fixed. The type of fluid is selected is water. Thus, here the parameter that we'll use in the calculation. Basically, the parameter that we use is density, dynamic viscosity, and lift coefficient, and lastly, volumetric flow rate. The first calculation is on the velocity maximum and velocity average. This equation was obtained from previous study by Melifan on 2011. We can use microfluidic calculator from Google to ensure that we are doing a correct analysis on the spiral microchannel. Next is simulation using COMSOL. Basically, the physics that we will use is laminar flow and stationary condition. According to the thesis from C.Y. Schultz in 2015, they studied that the fluid flow that through the microchannel acts as laminar flow. They stated that the inertial forces can result in the induced migration of cell or particle across streamline in laminar stream. Next, fluid properties is water. According to the study by Aman Razan in 2009 on the differential initial focusing of particles in curved low aspect ratio microchannels, they are using water to suspend the fluorescent polystyrene particles of 10 micrometer and 20 micrometer size. The boundary condition that I've used is as stated here. And next is meshing and grid independent test methodology. So here is my grid independent test on 600 micrometer times 100 micrometer, which is on aspect ratio 1:1. And here is the aspect ratio 1:2, which is the dimension 600 micrometer times 1200 micrometer. Next, I will go on result and discussion on velocity analysis. Here is the velocity profile for aspect ratio 1:1. And here is velocity profile for aspect ratio 1:2. According to knowledge, the focusing of particle bands is observed as the channel aspect ratio changes from 1:1 to 1:2. As the channel height decreases, the region with inward flow direction, which is close to top and bottom wall, become larger and the secondary flow velocity increases too. Hence, the strength of the thin flow increases as the channel aspect ratio changes from 1:1 to 1:2. Comparing the research with knowledge, the results obtained are quite different. The difference is because knowledge is reducing the height of the microchannel. Thus, the aspect ratio 1:2 in her study is different from my study. Somehow, we can relate that as the DH value is decreased, the strength of DIN flow will increase. The magnitude of DIN vortices increase with increased fluid velocity due to higher centrifugal force acting on the fluid. Finally, I will discuss on my result and discussion on drag force and lift force analysis. Here is the result for Reynolds number and DIN number and my calculation done for drag force and lift force. Based on the data, the drag force calculated is higher at aspect ratio 1:1 for both particle size of 6 micrometer and 20 micrometer compared to aspect ratio 1:2. While for the lift force, the relationship also same, where the lift force for aspect ratio at aspect ratio 1:1 is higher compared to aspect ratio 1:2. In addition, observe that the aspect ratio 1:1 experience a greater shear rate force from the wall even the DH number of aspect ratio 1:1 is smaller compared with 1:2. According to previous research by Ali Asgar in 2008, they find that the combined effect of this factor result in the formation of distinct particle stream based on their size, which in turn are collected separate outlet by taking advantage of laminar flow in the outlet's microchannel. This statement can support that these forces is developed to fulfill the cell separation which is required in the medical sector to detect cancer cell and other else. Lastly, my result and discussion on pressure drop analysis. Here is the result of pressure drop counter for aspect ratio 1:1 and here is the pressure drop counter for aspect ratio 1:2. Previous fabrication of spiral microchannel using polydimensional cellophane or PDMS done by Ani state that the limit of pressure drop is less than 1 kPa. The pressure must not more than that value or otherwise the fabricated spiral microchannel will fail. The pressure is obtained by identifying the difference pressure between inlet and outlet. Figure above shows the contour plot of pressure and its distribution. From the simulation result, the pressure inlet obtained for aspect ratio 1:1 is 787.31 Pascal, while for the aspect ratio 1:2 obtained that the pressure inlet is 241.8 kPa. According from this both results, we can see that the pressure drop is increasing as the width of the channel is increased. And here is the result and discussion to determine the error based on the theoretical pressure inlet and actual inlet. And from this result, we can see that the maximum error is just 6.74, which is reliable in this study. So finally, a further investigation on the effectiveness of the aspect ratio towards separation of cell need to be studied through experiment. This is because the result from an experiment is more reliable and more exact. This experiment can be done through the image J analysis by quantifying the amount of microbits at the outlet and inlet. Hence, the separation efficiency can be obtained and compared with other separation techniques. That's all from me. Thank you.